So piecewise functions are, well, I mean, like a function is something like, whenever you're graphing, primarily whenever you're graphing things and when you're first learning how to graph things, you're really focusing on functions. Okay. So functions they can be linear, like a straight line. They can be a parabola, right? They can do anything as long as there's something called the vertical line test. So the vertical line test, let me grab a pencil. Hi, I'm Sarah. I've been a STEM and math teacher, a STEM and math and science teacher for 20 years. And I'm here to make math and science engaging and fun and not so scary for everyone involved. If you're looking for private one-on-one virtual tutoring, please click the link and do the stuff. And let me know if you have any comments, questions, concerns, any content that you need help with. I have Cameo tutoring. I have all sorts of resources. So with the vertical line test, if you have a line that, like this one, we could have one like this, right? And then we could have one like, let's do one in blue, something like this. Okay. So the vertical line test is one way that you can figure out if it's a function or not. So basically, what a function is where you have an input that gives you an output that you know what it's going to be, right? So if I plug in 1, I'm going to get 5 every time. I'm not going to plug in 1 and maybe get 5, maybe get 6. Okay. So one way to check that is with something called the vertical line test. So if you pass a vertical line over your graph, then you can determine whether it's a function or not. So passing the vertical line test means that it's only going to cross through the line or the function in one place. Okay. So this curvy line here and this straight line here, two different functions, but they are both functions, because if you look, and actually, you know what? I'm going to change the color of this one. Let's do this one in purple so then we can really see. Okay. So the pink line here, even though it's curved, it's still, if I look at this vertical line, right, it's only going to pass through one spot. Whatever I plug in for my X value, I know what I'm going to get for my Y value, right? So here, if I plug in 2, I'm trying to get, all right. If I plug in 2 for my X value, I know I'm going to get -3 for my Y value, just always, right? If I plug in, let's see, if I plug in 0, I'm going to get like -3.5 for my Y value, right? So I can also look here with this purple line, right? So we're looking at this purple line now. Same idea, right? There's only one output for my input. So if I plug in 1 for this one, I'm going to get +4. Okay. Now this one here, this brown, this blue-green curve here, this is not a function, because if I look at it, right, it passes through that vertical line twice. Okay. So what that really means is that I don't know what I'm going to get out when I plug in my X, right? So I can plug in 1, 2, 3, 4, 5, 6, 7. So if I plug in -7 for my X, I'm either going to get 4 or 9. I don't know which one I'm going to get. Okay. So this is not a function. Okay. So this does not meet that definition of the function. Okay. So you do know what the values are going to be, but the problem is that when you put in your input, it's not an output. So you can still write an equation for this, right? Like there's equations for circles, but even circles are not functions because they don't pass that vertical line test. Okay. That doesn't mean they aren't a thing, right? They just mean that they're not a function. That's okay, right? It doesn't have to be a function. You can still graph it. But most of the time, especially when you're in Algebra 1, Algebra 2, the vast majority of equations you're going to be dealing with are functions, okay? So with these functions, oh my gosh, look at these cute little erasers that came with all of my dry erase boards. Are so cute. Okay, so a piecewise function, okay? So a piecewise function, I know I've said this a million times. Ooh, it's IE, right? Piecewise function. Okay. So I know I've said this a million times on this site and in these videos and everything, but mathematicians are not terribly creative with naming things. So piecewise function just means that it's literally a function that's split into pieces. That's it. A function that's split up into pieces. So when we look at this, we're looking at these functions, and so what it's going to look like is you're going to have your function sort of split up into different like areas or different kind of like spots. So a piecewise function is going to be where you have a function that maybe in certain ranges it changes, right? So with ranges it changes. Haha. So maybe it's, you have different limits for the x values. So let's just dive into this. It's a little bit easier to explain when we have an example. So f of x, which is function notation. So it just means that the function of x is, let's say we do 2x minus 3 when x is less than or equal to 2. Okay. And then we're going to say f of x is x squared. Oh, no, we'll just start with linear functions here. Yeah, when x is great, we'll just stick with that. We'll just start with 2 of these for now. Okay. All right, so here is our piecewise function. So what this means is that when x is less than or equal to 2, it's going to follow this line. But when x is greater than 2, it follows this line. Okay, so what I'm going to do is I know that x and 2, this spot here where x is 2, this is kind of like my change point, right? This is like my transition point. So anything less than over here is going to be 2x minus 3, okay? So what I can do is I'm going to figure out, all right, well, when x is 2, it follows 2x minus 3. So I'm going to do a table of values. So I have 2x minus 3, and I'm just going to make a table of values. And since I know this is a line, I know this is a line because there's no exponents on the x. So I can look at, all right, I know I want to figure out what that value is at 2. And then I want to pick a value that's less than 2 for my x because that's where else my line is going to go. Okay, so 2 and let's say 0, right? So we've got these 2 values. So when x is 2, I plug in my 2 for x. So I have 2 times 2 minus 3. So that's 4 minus 3. So that's going to give me 1. And then when x is 0, I've got 2 times 0 minus 3, which gives me negative 3. So I know that when x is less than or equal to 2, it's going to pass through these 2 points. Okay? So when it's 2, my y value is 1. Now I'm going to put a point there and I'm going to fill it in. Okay, now I'm going to fill it in as like a colored in circle because this little line here that means that it's or equal to 2 means that if x is 2, it is at that point. It is at 2 comma 1. So then I've got 0, negative 3, which is my y-intercept. There we go. And then I'm going to grab my little broken ruler because I forgot to grab a ruler to keep here. Whoops-a-poopsa. So I'm going to draw my line here. Just going to connect these 2 dots. Okay. Got a little bit bloopy. Okay. Now, I know that my line is only going to be that part, right? Because if x is greater than 2, it's not going to be following this line anymore. It's going to switch. It's going to jump up to that other line, right? So now when x is greater than 2, it's going to be following along with negative x plus 1. So negative x plus 1. Again, I'm going to figure out what it is at 2, right? So negative 2 plus 1 is negative 1. then I want to pick another value that's greater than 2, right? So we can do, I don't know, 5, right? The values don't really make a big deal out of that, right? Don't overthink it too much. You just want a value that's greater than 2 because x is greater than 2. Okay. So -5 plus 1 is -4. So at 2, -1, that's where my point's going to be. Now I am going to leave this as an open circle, right? Because it doesn't include that 2. Because if x is 2, remember, it's going to be at 2, 1. But anything that's greater, any x value that's greater than 2, it's going to follow this one. So then we've got 5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. It's going to go here. Okay. I'm going to connect my lines. There we go. Okay. So this is my piecewise function. Let's see if we can get all of these. We can get all of those on the screen. Okay. So what I've got is when x is less than or equal to 2, it's going to follow my orange line here. It's going to follow that 2x minus 3, right? When x is greater than 2, it's going to follow this -x plus 1, okay? So a piecewise function is really just like a function that's been split up into pieces, okay? Now here with this one, there's another piece that you might talk about, that your teacher might talk about, is if it's continuous or non-continuous. The easy way to think about that is if it's continuous, you can draw it without lifting up your pencil, okay? So that would be a continuous piecewise function. This one, I have to draw this, and then I have to jump down and then bring it down here, okay? There are no holes in this piecewise function. Sometimes there are holes, there are little gaps, right? But in this case, right here, even with this space, I'm still accounting for it. Like I can still get a value for x is 2, right? When x equals 2, there's still a value. It's x is 2, so y is 1. That's mathed up.